Hi, in this video we're going to have a look at Aether, what it was, why was it needed, and the Michelson-Morley experiment. Specifically, I'll be talking about the wave/particle nature of light. As I said, Aether and the reasons for its existence and why was it proposed, the properties of Aether, Aether wind, and what the Michelson-Morley experiment was trying to do, the result of the Michelson-Morley experiment, and then an evaluation of the experiment itself. So to start off with, light, there was a bit of a debate about light. Christian Hughes hypothesized that light was actually a propagating wave through ether. At the same time, Newton actually considered light to be a bunch of particles. Now, particles could explain reflection well, but things like refraction were harder to explain. And what Newton said was that light was traveling through this ethereal medium that was transmitting the vibrations faster than the light itself. So there was actually no clear argument either way whether light was a wave or a particle until Young demonstrated interference, and then he actually revived the wave theory of light. Interference, after that, they also showed that light was not just a wave, it was in fact a transverse wave. Transverse waves need a medium, and hence it revived Hughes' ideas of ether. Now, light travels from the sun to the earth, so therefore there must be a medium between the sun and the earth, and that medium is the ether. So ether must exist between the sun and the earth. In fact, ether must permeate all space. The problem though is that a transverse wave needs a medium to travel through, which was the ether, but the medium needs to be a solid. So ether needs to be a solid. But well, if ether is a solid, then surely, how can the planets go around the sun? Right? Surely they would have been stopped by the ether. So Gabriel Stokes actually developed a model for light in which ether was rigid for high frequencies and fluid at lower speeds. Thus, the Earth could move through it fairly freely because it was at lower speeds. However, it was rigid enough to allow light to flow through. Maxwell's equations required that all electromagnetic waves in vacuum transmit at a fixed speed. And ether was hypothesized to be this absolute and unique frame of reference in which Maxwell's equations hold. So ether was this thing that had these magical properties, right? It has to fill all space, it must be stationary in space, it's perfectly transparent because obviously I can't see it. It needs to have a low density and needs to have a great elasticity in order to propagate the light waves. It has to be massless and without viscosity. It had to be more rigid than speed. Now, that's a lot of contradictory properties over here. And even though physicists were actually aware of all these problems, the ether model was so entrenched that was simply assumed to exist. Everyone accepts that ether exists. Now the Earth travels through, goes around the sun. So as the Earth is going through the sun, so we have the sun over here, and we have the Earth over here. As the Earth goes through the sun, and there's ether all over here, we must have this thing called an ether wind. It's kind of like you're driving on a day and you turn the car windows down. As your car is moving through, you feel the wind, even though there's actually no real wind. Same thing over here, as the Earth moves through, we should experience an ether wind. The Earth actually travels at a tremendous speed, it travels at about 30 kilometers per second. And hence, as the Earth rotates around the sun, the direction and the magnitude of the ether wind should change. So the Michelson-Morley experiment was actually one of the most famous experiments in physics. It was the first strong evidence against the existence of ether. Although it never tried to disprove ether, Michelson-Morley experiment actually attempted to measure the motion of the Earth relative to the ether. It actually relied on the interference of two light rays that were traveling perpendicular to each other. So this is what the Michelson-Morley experiment roughly looked like.